Yeah, hi Karthik.
Okay.
Yeah. So let's start with today's session. So in the last session, I think we have seen the KNN part, right?
Hmm.
Yeah. So we have completed KNN concept and code and hyperparameters, etc. Right. So
Yeah.
now in this class, we are going to start with the next classification algorithm. So as I said, it is Naive Bayes. Okay.
Okay.
So yeah. So this Naive Bayes, see, each classifier will have specific concepts that are related to it. Okay. For example, what I mean by this is if you see linear regression, okay, we need to study about the distances, okay,
Yeah.
and errors, etc. Okay. And in logistic regression, we learned about lines,
Yeah.
right? Starting with some random line and changing it.
Hmm.
In SVM, we studied about planes.
Hmm.
Correct. So
Yeah.
planes, support vectors, and errors, margin, those are its related concepts. Fine.
Yes.
Similarly, in neighbors, the the main concepts are probability.
Yes.
Okay, so
Okay.
neighbors is completely based upon probability, and it is actually a kind of probability itself. So
Okay.
now, as I said, so each algorithm, all of these algorithms are related to each other in some or other way. At least
Okay.
the logistic SVM and the naive Bayes. Okay,
Okay.
so we have seen similarities between logistic and SVM, right? There also we are in logistic we are trying to find out the line. In SVM, we
Yeah.
have upgraded it to a plane.
Fine.
Okay, but the idea is to find out the best
Fine.
line or
Yes.
plane which separates with maximum efficiency or minimum loss. Correct.
Yeah.
There also, if you remember, we are finding the probabilities. Okay, so in the code we have seen the predict proba, right?
Yes.
So that means what it is telling, what is the probability of this particular in out I mean test point to uh, belong to this output class, whether it is output class 1 or output class 2 or output class 3. Fine.
Hmm.
So ultimately, mainly in logistic regression, if you remember, so we are in a sense we are calculating the probability, because if you see, we have the threshold. By default, it is threshold is 0.5. So if anything greater than 0.5, we are considering it as class 1. Anything less than 0.5, we are considering it as class 0. So when you just do some input dot predict, the output you will see is either 1 or 0. Okay,
Yeah.
either 1 or 0, but it is not directly 1 or 0. In the background, it is actually giving us probabilities, and whichever the probability is greater than 0.5, the output is becoming that. So if
Yeah.
probability of 0 is greater than 0.5, it is becoming that the other way around. Okay,
Yeah.
but actually what it is calculating is it is just calculating the probabilities.
Hmm.
Correct. So
Yeah.
in even in SVM also we have seen the predict proba function. So there
Yes.
also we can have the probabilities. Okay.
Yes.
Now coming to neighbors, it is actually the main probabilities that is what we are going to see, and it is completely based upon the probabilities itself. Okay,
Yeah. Okay.
fine. So this is and uh, naive Bayes is also, I would say, simple algorithm. Okay, if you understand few probabilistic concepts, then it is very easy to understand naive Bayes. Okay, and the two fundamental things is we'll see why it is called naive and what is Bayes. Okay,
Okay.
and why it is called naive Bayes. Okay, so that we will see. But to reach that stage, so we need to understand some basic concepts. Okay, we can
Okay.
directly study that, but that will not be very helpful to you. Okay,
Okay.
so we will see some foundational concepts, few small concepts. From that, we will try to understand what is naive Bayes. Okay,
Okay.
clear?
Yeah.
Okay. So few basic terms or terminology you need to be familiarized when you are studying naive. Okay, are these okay? Very simple concepts. So when I'm saying a probability, right? So that means what? Probability will be always between 0 and 1. I think we all know
Yeah.
that, right?
Yeah.
So that means when I'm saying, for example, if you invite me to a party, okay. So if I say, hey, I'll probably come, right? So that means what? There is probability that I won't come, and there is a probability that I will come. Okay. So
Yeah.
the two possible outcomes are coming and not coming. Okay. So some probability is coming, and remaining one minus the probability is not coming. Correct.
Yeah.
So the experiment what we're doing is the party. Okay.
Hmm.
So or fine. So in that there are few outcomes. Okay, coming or not coming. In that, what is the output? Okay, and what is the probability of that? So this is the things we are going to see. So, for example, as we see here, what is an experiment? Experiment is a carefully planned procedure under which we, under carefully monitored conditions. These are just definitions, okay? So, just for your idea, okay? So, see, experiment include like tossing a coin, rolling a dice, drawing a card from a well shuffled deck of cards. So, all these are experiments, okay? So, only when
Yeah.
you do some experiments, then only based upon the output, you'll calculate the probabilities, okay? So, and sample space is what? Sample space is the outcome of the result of an experiment. So, for
Yeah.
example, if you throw a dice, okay, what are the possible outcomes? It could be either from 1 or between 1 and 6, right?
Yeah.
All the possible outcomes are the sample space. Okay.
Yes.
So, whatever the outcome that is possible, the list of that or set of that is the sample space. Fine. And in that, then an event is outcome of a random experiment, and see, that means that one output from that particular random experiment, the experiment which you're conducting, right? So in that, the overall possible outcomes are 1, 2, 3, 4, 5, 6. If you
Yeah.
consider the case of rolling a dice, each
Mm.
one of there is called an event. Okay, if you roll a dice, okay, and it got 5, one event has happened.
Mm.
You rolled a 2, you got 2. The one other event has happened. Now, the rolling a dice is an experiment. All the possible outcomes are sample. Every each possible outcome, if you consider one particular outcome, that is an event. Okay. And based upon that, then you can say what is the probability of this event or what is the
Yeah.
probability of that event, etc. Okay. So, what is random variable is a variable which is an function that assigns to outcome of an experiment. The random variable can be discrete, okay, continuous, random variable, whatever the value you are getting. Okay, and yeah, so here the main thing. So one is the exhaustive events, and what one is the independent events, one is the conditional probability. Okay, so now, so we will try to understand few things in deep. Okay, so when you are rolling or when you're conducting an experiment, right? So
Yeah.
that is an event. Okay, so there could be two types of events. Okay, so
Mhm.
one is independent events and one is dependent events. Okay, so that means, for example, if I say you are rolling in you are tossing a coin, okay, so you have tossed it 10 times, okay,
Mhm.
and you got some like 7 heads, 3 tails, etc. Now if I
Mm.
ask you, now if you're tossing for the 11th time, now what is the probability of getting a head?
Total?
Total 10 times I've tossed,
Yeah.
okay, I got 7 tails, 3 heads.
Hmm.
Now 11th time I'm tossing, now what is
Mm-hmm.
the probability of getting a head?
50%, 0.50.
50, correct. So
Hmm.
that means all that has happened before this has no dependency of
Correct.
11th time, right? So even if you toss 10,000 times also, the
Yeah.
next time when you toss, again it will have 50-50 probability, right? So there is
Correct.
no dependency between two events.
Yeah.
Clear? Now, in other case, for example, if you consider dependent event, so I said there are a set of cards, okay?
Hmm.
So playing cards. So in that, normally if you pick a card, so I think there are total 52 cards. So the probability of getting any one card is like if you consider all different cards, it will be 1 by 52. For example, if I say already I have picked up a spade,
Hmm.
okay, now what is the probability of picking another spade? So then it is not a directly 1 by 52, right? So because
Correct.
already one you have picked up, so the probability of picking a spade is now less,
Correct.
correct? So that those are dependent events.
Yeah.
Getting
Yeah.
correct? So like that. So these are some basic examples, but you can apply to it to our real life, and you can see many examples. Okay, for example, see, you applied for a loan.
Yeah.
If you are a normal person, so what is the probability of getting a loan? 50-50,
Correct.
right? But let's say your CIBIL score is, provided that your CIBIL score is greater than 850. Now, what is the probability? A bit more.
Correct.
Correct? But let's say other way, you are a defaulter.
Mm-hmm.
Okay, you have already took loans from some other bank and you did not repay. Given
Yeah.
that, now what is the probability? So it's not 50-50, right? So these are
Correct.
dependent events. So your current loan is dependent on your previous loan.
Correct.
Agree? So
Yeah.
that those are dependent independent events. Okay. And so when the occurrence of one event has no bearing on occurrence of other, so those two events are called independent. That means if there is no dependency, obviously it's called independent. Okay, so in
Correct.
that case, what is the probability of A and B is probability of A into probability of B. That means
Yeah.
there is no dependency. So if you want to calculate the both the probability, that means probability of A into probability of B.
Yeah.
Simple. Okay, so fine. And okay, so what is exhaustive? Two or more events associated with random experiment if their union is sample space. That means exhaustive events are those when you combine all these events, right? So it will give you the sample space. That means, for example, rolling a dice. So sample space considers 1, 2, 3, 4, 5, 6. Okay. This is
Yeah.
sample space. Now each one of these is an event.
Hmm.
Okay. So for example, I consider two events, 1 and 4. Okay.
Yeah.
Now, these are two events. But those are not exhaustive events because adding 1 and 4 is not giving me sample space. Okay. When you
Yeah.
consider all these individual events, that will become an exhaustive events because we are considering all the events where the union of these exhaustive events is a sample space.
Okay.
Okay. Just few
Hmm.
definitions. Fine. So now, okay, but mainly main things over here are dependent and independent events. Okay. I hope you
Okay.
understood dependent and independent.
Yeah.
Now, when you are having independent events, it is directly because there is no dependency. So you need to take the probability of A and probability of B.
Okay.
Correct?
Yeah.
Now, when you are having dependent events, you
Mm-hmm.
cannot directly say A and B because A is dependent on B and B is dependent on A.
Yeah.
Any which way, there is some relation between them. So you cannot directly do A into B.
Okay.
In that case, we will do conditional probability.
Okay.
Okay, because they are based upon a condition.
Okay.
Clear till this point?
Hmm.
Fine. So now let's say A and B are two events associated with random experiment. Then the probability of A occurrence under the condition of B has already occurred. Okay. So when I'm saying
Okay.
condition means probability of A given that B has already occurred.
Okay. Yeah.
Okay. So in that case, I think we all studied this probability in or
Yes, yes.
definitely in our
True. True.
10th or inter, right? So just a
Interviews also.
refresh.
Yeah.
Okay. So here probability of A given that B has already occurred.
Hmm.
Okay, it is that. If B has not occurred, then it is zero.
Correct.
Provided that B has already occurred, then what is the probability of A? So it is probability of A and B. A and B in the sense it is A intersection B
Yeah. By probability.
by probability of B.
Yeah.
Okay. So this is a called conditional probability.
Yeah.
Clear?
Okay.
Fine. So now from here, we have something called as Bayes theorem. Okay. From this conditional probability itself, we derive something called as Bayes theorem, and that is the
Hmm.
fundamental of Naive Bayes. Okay.
Okay.
So you'll be surprised, like these are very simple concepts. Okay. But using this, we can actually solve some good problems. Okay. So
Yeah.
we'll see. So now when you see conditional probability is this. Now, what is Bayes theorem is saying? Bayes theorem is saying, okay, probability of A given B. Okay, same thing. Conditional
Yeah.
probability is saying probability of A given B is probability of A intersection B by probability of B.
Hmm.
Bayes theorem is saying is it in a different way. That means probability of A given B equal to probability of B given A
Mm-hmm.
into probability of A, probability of B. Okay, this the simple way to write here is okay. So anyway, so probability of A by B or anything input given output. Okay, so anything
Hmm.
A by B is the simple way is given A by B. So it is simply probability of A by probability of B. Okay. If
Mm-hmm.
you're asking for
Mm-hmm.
A by B, first probability of A by probability of B into probability of B by A.
Okay.
Okay. Same thing I've written. So it's like probability of A by B into probability of B by A. Same
Yeah.
thing. Okay. The easiest way is given A by B, it is A by probability of B into probability of B by
Yeah.
A.
Yeah.
Give clear? Any confusion?
Yes. No. No. No.
Okay. So now let's see from here, how did we come here? Okay. It's very simple. So you know this probability of A by B is A intersection B by probability of B.
Correct.
Okay. So now what I will do, now can you tell me what is probability of B by A?
Probability of A intersect A and B by probability of A.
By probability of
A.
A. Okay.
Hmm.
So this I'm sending here. So then what it
Yeah.
will become? So instead of writing, I'm just writing it here. So this will become probability of A.
Yeah.
Oh, sorry. Probability of A equal to this. Okay. Now
Mm-hmm.
this also I will send here. Okay. So this I'll send here. This will become probability of B into this.
Yeah.
Agree? So now this is probability of A intersection B equal to this. This is also probability of A intersection equal to this. That means what?
Yeah,
This equal to this,
correct.
correct? So when I equate this into this, and if I want only this, I want only probability of A by B. So now probability
Mm-hmm.
of A by B equal to what? This one,
Yeah, yeah.
probability of B
Probability of B by
by
A
A into
into
probability of
probability
A
of A by probability of B.
by probability of B.
Hmm. The
Correct?
same which we got here.
Same thing over here.
Correct.
Okay. So it's clear, right? So I just
Yes,
wrote
yes,
it
yes.
here.
Yeah, yeah, clear.
Fine, right? Okay. Same thing. So when you, from here only, we can easily derive this.
Yeah, got it.
So now this is a Bayes theorem.
Hmm.
Correct? So now here, usually it's called, yeah. So over here, if you see, probability of A by B is probability of A being true that B is true. So B is true means B is already given.
Yeah,
Okay. So probability of the way how you read it is probability of A given that B is already given equal to probability of B given that A is already occurred
yes.
into probability of A, the actual probability of A and actual probability of B. Okay.
Yeah.
Any doubts here? Simple formula.
Okay. No, no.
Fine.
Okay.
So this is the Bayes theorem, but usually, people use some other names also. So, for example, if you see the Bayes theorem, they call it as posterior. Yeah. So it's called posterior probability.
Okay.
So the terminology. Okay. So since we are studying, so if someone asks you about this, so if you can just know this. So this is called whatever you're calculating, right? It's called posterior probability, Karthik.
Okay.
So just the naive-Bayes terminology. Okay. So this is called posterior probability. This is called likelihood probability. B by A.
Okay.
Okay. And P of A is called prior and P of B is called marginalization. Okay. Just names. I am also not sure why they call this. Okay. So it is out of scope also. So I don't call by these names. Okay. We'll say probability of A given B. Okay. But just in case if someone asks you, hey, do you know posterior likelihood? Then you can remember this.
Okay.
Okay. Just the names. Same formula. Okay. Fine. So now this is fine, but I always feel that probability can only be understood with examples. Okay. So if you just study concepts, sometimes it is confusing. Okay. So we'll solve two examples. Okay. So that our concepts become a bit better. Fine. Uh, you're good till now, right? You understood, right?
Yeah, yeah.
Okay, fine. So let's solve this problem. So here it is saying there are three urns. Urns means vessels. Okay, boxes, anything. Okay, contain. First urn contains 6 red and 4 black balls, and second contains this 4 and 6. Third contains 5 and 5 black balls. 5 red and five black ball. This is first vessel. This is second box. Let's say box. This is third box. Okay.
Yeah.
Now these are there. One of the box is selected at random.
Mm-hmm.
I don't know which box he has selected, and one ball is also drawn from it.
Yeah.
If that ball is red, find the probability that it is from the first box.
Okay.
Okay. So
Mm-hmm.
let's try to solve this. For example, what he's asking, let's write it out. He's saying the ball is red.
Mm.
Already he's saying the ball is red. That means the red is fixed. But if the ball is red, find the probability that it's drawn from first box.
Okay.
Okay. I'll say B1.
Mm.
Fine. So here it is saying same like, so probability of A given that B has already occurred. So what is already occurred? The ball is already red. Red is already occurred. Okay. The probability
Yeah.
of red, but I don't know from which box it is, one or two, that I don't know. So he's asking what is the probability that it is from the first box.
Mm.
Fine. So here, so what I will do, probability of B1 by R equal to probability of B1 by probability of R,
Mm.
correct, into probability of R by B1. Agree?
Yeah. Yeah.
Okay. So as I tell you, so if anywhere if you are missing track, right? So just stop me so I can revise it. Okay. But make sure that you understand without any confusion. Okay. So this is
Yeah.
formula. I hope you are clear. Now,
Clear.
you see probability of B1, probability of taking box one. What is that? So total how many boxes are there? 3 boxes.
$3. Yeah.
Okay. So then probability of B1 will be 1 by 3.
Hmm.
Overall 3 in that picking first box is 1 by 3. Same for second box, third box also.
Yeah.
Correct? That's fine. Now, probability of, okay, picking a red one from the box B1.
Hmm.
Okay, now probability of picking, given that it is box B1, what
Yeah.
is the probability of picking a red one? Okay,
Hmm.
so now that means what I'm saying, hey, now this is box B1. In that, what is the probability of getting R? Actually, in box B1, how many balls are there? 6 plus 14.
Red balls. 10 balls are there, but out of that, one is only one red ball.
Why only one? Who said one?
I mean, six red balls.
Okay, 6. Okay,
Yeah.
correct. So,
Mhm.
probability of B1 with respect to R, sorry, red, probability of uh, red, given that already it is box B1 is 6 by 10 because B1 is having overall 10, in that red
Mhm.
are 6.
Yeah.
Same thing here. Overall boxes are 3, in that B1 is 1.
Yeah.
Only 1. Okay, clear?
Hmm.
Right. So now coming to this probability of taking a red ball.
Hmm.
Okay. Now this is important. So taking probability of taking a red ball is what? So here it is interesting. So probability of red ball, picking a red ball means what?
Hmm.
So the red ball can be picked from which box? Either box 1, box 2 or box 3.
Yeah, but they have given you here box one, right? First
Correct.
box. Hmm.
Correct. But we don't know what. See, this we need to find out. Okay. To find out, this is the formula. So
Okay.
probability of B1, we already found out. This is
Hmm.
fine. Probability of R by B1 also we know.
Yeah.
Now probability of red is what? Just to take a red is what?
Mm-hmm.
That means the red can be picked from. Now we want to find out this. Okay. Now forget about this.
Yeah.
Yeah, we have this formula. So in this, we already know. Just focus on this one, P of R. If you know this, we'll substitute this, we'll get this value. Simple,
Okay.
right? So now probability of R means what? Just probability of picking up a red.
Hmm.
It is just the red. I'm not talking
Hmm.
of any boxes.
Okay.
Because P of R means what? Probability of taking a red. That's it.
Yeah. Okay.
But now
Got it.
red can come from anywhere. One or
Correct.
two or three. So
Hmm.
here we use something called as law of total probability, Karthik.
Mm-hmm.
Okay, so here I have written. So law of total probability is what? So the total probability of getting R is from box 1, box 2, box 3. Okay,
Okay.
but we don't know from which box I'll pick. So again, you should
Okay.
use the box probability also.
Okay.
Okay, so the idea is probability of getting R is probability of getting red from B1.
Yeah.
Okay, see here the probability of red. See, I'll tell you. If this is a bit important. So if you understand one example, right? So it is easy to understand every other example. So when I'm saying red box, so red could come from box 1 or 2 or 3. Correct? There are
Yeah.
only
Yeah.
3 boxes. But I
Hmm.
don't know. If you tell me, okay, I if red is coming from B1, then
Mm-hmm.
what will become? Then it will become this because I'm telling here what is the probability of getting red from B1. So then that is 6 by 10.
Yeah.
If you tell me second, then it is something. Third, that is something. But I'm not talking about that. I'm just talking the plain act, the overall probability of red.
Probability. Hmm.
That means what? Then I should consider every box.
Yeah.
Correct? So now here probability of B1, B2, B3. So that means what? Probability of getting red given it is B1.
Mm-hmm.
Okay. Plus probability of
R
red
by
given
B2.
it is B2.
Plus
Okay.
the
Plus probability
probability
of red given it is
by.
B3.
Yeah.
Okay. E3. But
Hmm.
wait. Here into here I'm saying probability of red given it is B1. Fine.
Hmm.
But I'm not tell who is telling me B1. Here nobody is saying B1, right? So I'm just
Correct.
asking only R. So here I'm
Yeah.
considering it could be B1, it could be B2, it could be B3. Getting?
Yeah. Hmm.
See here. Listen carefully. I'm just looking for P of R, but I don't know R could come from where. It could come from 1 or 2 or 3. So I'll
Yeah.
consider each probability. But when I'm saying here probability of red from B1, that is 1. But how can I consider only B1?
Yeah.
That's why I'll consider B2, B3 also. That's fine. But first of all, when I'm saying probability of getting R from B1, so that means
Mhm.
what? I'm taking B1, right? So, but what is the probability of getting B1?
Yeah. Okay.
Correct? Now, what is the probability of choosing B1? That is probability of B1. We should also multiply with its B1 probability also.
Okay.
Okay. Here also we should multiply with probability of B2 also.
Mm-hmm.
Here also probability of B3 also.
Okay.
Is it clear, Karthik?
Yeah.
Right. So here probability of red is probability of red from B1, okay, into probability of
Mm.
B1. That means first of all, what is the probability of choosing B1? You need to get,
Correct.
now once you have picked B1, in that what is the probability of R?
Correct.
Correct. That means first I see, it's like first I need to pick red. I have three boxes in front of me. I need to pick red, but I don't know which one I will pick. Correct. First of all, I let's say I am picking first box.
Box
Picking
probability.
means what is the
Then
probability of picking it? So it is 1 by
yeah.
3. That is this.
Yeah.
Okay,
Yeah.
now I
First
took the
box
box B1.
probability.
In that,
Yeah.
what is red? That is this one.
Got it. Got it.
Over.
So
Again, next time going for B2. What is the probability to pick B2? That is this.
yeah.
In
Yeah.
that, what is red? This.
Correct.
B3 is this. Clear?
Correct.
Okay. So this one, we can also see it in slightly different, this one also. So for example, if you see here, we got this right? So
Yeah.
one way to understand this is, for example, if you see in our conditional probability, so when you are saying probability of R, so
Mm-hmm.
it could be from B1, B2, B3. That means what? Probability of R and B1.
Yeah.
Okay. Probability of R and B2. Okay. Plus probability of R and B3.
Yeah.
Okay. So see, you understand carefully the difference between R by B1 and R and B1.
Yeah.
R by B1 means given B1, in that what is R?
Hmm.
R and B means what? Both are occurring at the same time.
Yeah.
Okay, both are occurring at the same time. B1 and R means already B1 is occurred.
Yeah.
Now, what is the probability of R? R could occur
Hmm.
or not occur, I don't know. But B1 is already occurred. Now, what is the probability of R? That is R by B1.
Yeah.
Okay, but R and B1 means both are occurring.
Hmm.
Okay, so now if you see this R and B1, so
Hmm.
for example, if you see from conditional probability, what is this P of A by B equal to P of A intersection B by B of B?
Correct.
Okay. So here, if you see, I'll write P of R by B1, right? So I'll just
Yeah.
focus on this P of, I want this. Okay.
Yeah.
So this is one way. What we
Mm-hmm.
have wrote is this is one way. This you
Yeah.
understood, I think.
Yeah.
Okay.
Yeah.
The another way is if you think in simple terms, what is probability of R? That means R falling in B1 plus R falling in B2 plus R falling in B3. Okay.
Correct.
Now, when I say R falling is B1 means what? It is red and also box B1. That means this.
Correct.
And this and this. So if you try to find out this R and B1, so if I go here, so in this formula, what is probability of A intersection B? Probability of B by A into
B2.
probability of A.
Correct.
Okay. Or the other way around. Okay. So over here, I can write it as probability of what is this? R intersection B1. Okay.
Yeah.
R intersection B1 equal to probability of given B1, what is R? Okay, into probability of B1.
Yeah.
Same thing, right? So A here is B1.
Hmm.
Okay, so and B here is R. Okay, so A intersection B formula is this. So I'm writing it in the same way. So R intersection B1 is probability of R by B1 into probability of B1. Okay, so I think you can choose this formula. Is it clear or is it confusing?
Oh, clear.
Clear, right? So from conditional probability also you can pick that. Okay, so that's uh, that's how you can get to this formula. Okay, so it is basically when I'm saying P of R is probability of R from B1 into probability of B1 and
Yeah.
R by B2 into B2, R by B3 into B3. Okay,
Yeah.
fine. So now this is completely P of R.
Yeah.
Okay, so now what is R with respect to B1? R with respect to B1 is 6 by 10.
Hmm.
Okay, 6 by 10 into what is probability of B1? 1 by 3.
1/3.
Okay, plus probability of what is B2? Again 1 by 3.
Same 1/3
Into
into
probability of R with respect to B2. That means in B2, what is
4.
probability of R? In B2, it is
4/10.
4 by 10. Okay. Plus again, probability of B3 is what? 1 by 3.
1/3 into 5/10.
5 by 10. Okay. Now what is this? This is P of R.
Yeah.
When you
Yeah.
calculate this, it is P of R, okay? And you also have P of B1 and P of this one. When you put everything, you will get probability of B1 by R.
Correct.
Clear?
Clear.
Okay, fine. I hope it's clear. Okay, fine. So
Yeah.
now let's see one more example. Okay, so if this is slightly confusing, right? So let's see one more example over here. So it will be more clear. Fine. So same thing. Here I'm saying an insurance company insured 2,000 scooters, 4,000 cars, and 6,000 trucks drivers.
Hmm. Hmm.
Okay. Now probability of accident involving scooter, car, truck is 0.1, 0.1, 0.3, 0.05. That means for scooter it is 0.1,
Hmm.
car, and this is truck.
Hmm.
Now, one person meets with an accident. What is the probability that is in scooter?
Okay.
Okay. So first you need to formulate the formula. Okay. That means what he's asking, what is given? Given is
Hmm.
that one of the
Probability.
person is met with accident.
Hmm.
That is given.
Yeah.
Accident has happened. That is given. What is the probability that he is having scooter?
Hmm.
Okay. So you are having only three vehicles: scooter, car,
Yeah.
truck. Now
Yeah.
accident has happened. Now accident has happened means it could happen with the scooter or car or driver
Car or
or
truck.
truck.
Yeah.
Any of this person met with an accident. Only three
Yeah.
options. Okay. We don't know which person. Now
Hmm.
he's saying accident has happened, but what is the probability that is a scooter driver?
Yeah.
It could be car driver also, it could be truck driver also. I don't want those. I want what is the
Correct.
probability that is a scooter. Okay.
Hmm.
Now what is the formula? Can you tell me what is
PR
the formula?
S by uh
P of
yeah,
S
S.
by
I mean, we can write in two ways, right?
correct. Yeah, you can write two ways. So I usually write because S and A are there. I'll just write S and A first.
Okay. Then
P of
into
uh,
A by S.
correct into A by S.
Hmm.
Okay.
Hmm.
Fine. So this is a formula. Now once you write in formula, it's very simple. So what is probability of scooter,
Scooter.
probability of accident with respect to scooter, and probability of the oral accident?
Excellent. Correct.
Okay. So now if you see first, what is the probability of scooter? So probability of scooter is what? So actually the probability that the driver is from scooter, that he's a scooter driver.
Correct.
There are three different types of
2000.
drivers. Okay. So overall, how many drivers are there? 6 plus 4 plus 2,
4.
12,000.
12,000 by 2000.
2,000
2000 by
drivers are
12.
there.
Only scooter is 2000.
2,000. Okay. So this is the probability of how much is this? 1 by 6.
1 by 6.
1 by 6 is a probability that he is a scooter driver.
Yeah.
Okay. That's fine. Now, what is the probability of
A
accident?
with respect to scooter.
How much is this? Can you tell me?
Probability of uh, A with respect to scooter, right?
Hmm.
Already scooter is given.
Right. So, no, if you see this, the probability of accident involving scooter
Scooter. Yeah,
0.01.
0.01.
This is 0.01. Okay.
Yeah.
It's the same thing, right? So, he's saying
Yeah,
accident
cycle they have given. Yeah.
involving a scooter driver. That means he's saying it is a
Zero-
scooter driver and also accident has happened. That is 0.01.
0.01. Yeah.
Okay. Clear?
Hmm. Now we know
Now,
probability of A.
probability of overall accident. Okay.
Yeah.
So, now just
Hmm.
like I said, so probability of accident means accident can occur from any three different ways. Okay.
Correct.
So, that means we'll consider all three ways.
Correct.
And again, the probability of occurring each way. Okay.
Correct.
Now, probability of accident could be, see, scooter or car or truck.
Correct. Yeah.
Okay. So, first of all, what is the probability of picking up? First, I will pick scooter. Okay. What is the probability of scooter? Then,
Mm-hmm.
probability of accident with respect to
But
scooter.
with respect to scooter.
Okay. Plus, next I'll pick probability of car.
Mm-hmm.
Okay. Once it is picked, then probability of
Car
ac-
by
in that car, what is the probability of accident?
yeah.
Okay. Next, probability of truck.
Mm-hmm.
What is the probability of even
Accident with a truck.
the probability that accident is happening?
Yeah.
Okay.
Hmm.
Fine. So now if you see what is the probability of S 1 by
1
6
by 6,
into probability of accident with respect to scooter is
0.01.
okay. Plus now what is the probability of car? Car is 4,000 by 12,000.
Yeah.
1 by
1 by
3.
3 into 0.03.
Okay. Plus what is truck? 1 by 2
1 by 2 into
into
0.015.
0.015. Okay. Now this is the probability of accident happening.
Total accident. Yeah. Yeah.
Okay. So when you calculate this, you will get this. P of S you already know. P of A by S you already know. When you put
Yeah.
everything, you will get the
Only
value.
with respect to scooter. Yeah.
Only with respect to scooter.
Yeah.
Okay. So similarly, you can also calculate truck T by A.
Hmm.
By A.
Anyway, this is the same. Just only A by S will change and P by
Correct.
S change.
Correct. So in T by A, what will change?
P by A means only the 1 by, instead of 1 by 6, we have to give 1 by 3 into
Yeah.
0.03.
Correct. Only the numerator will change. Okay.
No,
So for P of S by A, we took P of S, right? So for P of let's say C by A, here we'll get P of C
by
into P of
left C by A.
A by C.
Sorry, A by C.
And here denominator P of A. Now P of A is common. So again you need to use
Common, yeah, yeah,
everything.
that is
So this
common for
will be
P.
common for S and A, C and
Also,
T.
yeah,
Okay, only the numerator will change.
correct.
Correct? For T you will have P of T into P of T by C. Sorry, A by
Yeah,
T.
yeah.
Clear?
Hmm.
Fine. So now I think we had like some basic idea like what is conditional. These are all conditional probability.
Yeah,
If you see this probability of being a scooter, it is a independent. Okay, picking just it is a scooter or car or truck is a independent event. Okay, so that's why
yeah,
there is no condition. But A by S is dependent. Already
correct.
it is scooter, then what is the probability of accident?
Yeah, yeah.
This is also dependent. Already it is an accident. What is the probability? He is a scooter driver.
Hmm.
Okay, these are conditional probabilities. Okay, so
Yeah.
for that we have this formula.
Mm-hmm.
Um, okay, so I think you are clear with the formula also, like how
Yeah,
you
yeah,
can
okay.
derive the you know how you can derive the Bayes theorem from the conditional probability.
Yeah.
Okay, so with this uh, we have seen few examples, right? Okay, so now when you see about this, right? So this is clear. Now how are we going to apply this to our actual problems? Okay, so that we will see a bit later. Okay, but I'll just give an intuition, because since you already understood like what is happening here, right? So I'll give you some intuition. Okay, but before that intuition also, we will see one more few more examples.
Okay.
But these are a bit next level examples. Okay, and
Mhm.
with this you can, once you understand this, right, so directly you can understand how naive Bayes is used for actual purposes for the classification. Okay, so
Okay.
naive Bayes is usually used for one example called as text classification.
Okay.
That means what, whether this is a spam or not spam is a famous example. Okay, that means when you write
Oh.
something, you got a mail, right?
Mm-hmm.
So based upon some text in the mail, whether it is a spam or not spam. So to find out this, Naive Bayes works very well. Okay, so
Okay.
classifying the text and sentiment analysis, we say that means let's say you opened a restaurant and let's say you are asking for the feedback. So many people on the first day they wrote some feedback. Okay, and then when you feed that to the Naive Bayes, so you can say how many are positive, how many are negative,
Okay.
what is the basic sentiment, and whether your food is good, bad, ugly, etc., etc.
Okay.
Okay, so mainly for text classification. So that we will see uh, later. Okay, but before jumping that, we'll solve like two examples, so which will make our foundation bit stronger in the probability. Then we can go into that concept. Clear?
Okay.
Okay. So, but theory part is just this. Okay, so just if you understand these two small formulas, conditional probability and Bayes theorem, mainly this, it's not that difficult. Clear?
Okay.
Okay, fine. So now coming to this, right? So there are uh, two concepts. I'd say mainly one concept we'll see. Okay, and that is over here. So when I'm saying the same thing, so it's writing the same Bayes theorem. Okay, in a different form. So Bayes' theorem is saying what probability of A given B equal to probability of B given A by probability of A by probability of B. Okay. So now
Yeah.
when you try to apply to, for example, this one, right? So basically, when I'm saying this is a classification problem, what I'm saying, Karthik, so these are my input, this is my output.
Yeah.
Correct. So if you talk in now the terminology, Navier-Bayes terminology, so what we are
Probability.
saying, what is given this,
Hmm.
what is the probability becoming 0 or 1? Clear?
Yeah. Hmm.
Clear? So
Yeah.
the just like how we are given it is a scooter, what is the probability that he has met with an accident? In the same way,
Yeah.
I'm saying, given my input features, okay, input features, what is the probability of it is becoming 0
Whether
or
he survived. Yeah. Survived or not? Yeah.
surveyed or not? Correct? Same thing. We have drawn to same concept. Fine.
Yeah.
So this problem can be say I'm saying given the passenger class is 3 and he's a gender and age is this. Tell me what is the probability of his surviving. Tell me the probability of not surviving. Whichever the probability is more, the output will be that.
Yeah.
Clear? So
Yes.
it's just calculating the probabilities. Fine. So I hope you are able to draw similarity between these two.
Yeah.
Okay. So same thing I have written here. So now probability. So our in our case this example, right? So we will be having many features.
Hmm.
Okay. Output classes are like one, maybe only two or three binary or multi-class classification. Okay.
Yeah.
So here, if you see what it is saying is what is the probability given this? What are x1, x2,
Hmm.
x3? Those are my
Feature.
features.
Yeah.
Given this, what is my probability of y? Correct.
Outcome.
Y could be 0
Coming.
or 1 output.
Yeah.
So this could be pass or fail, spam or not spam. Okay. Getting?
Yeah.
Yeah. So now here again the same thing. So here just like how we had the probability of if you see probability of A by B, okay, is what probability of you can write say let's say probability of B by A into probability of B by probability of A.
Mm-hmm.
Base theorem. So probability of A by B is this. Now probability of B by A means what? Probability of x1 with respect to y.
Correct.
Okay, so x1 with respect to y. Now, since we have many features, so you need to calculate for everything. x1 y,
Yeah.
x2 y, all x1 y. Okay, that means what? What is the so in this way, if I'm asking what is the probability of getting 0 given these features, okay,
Hmm.
that is this. I'm saying what is the probability of getting survived given all this. So
With
in the
all these
formula,
features.
what is the probability of getting gender as male given he has survived?
Hmm.
Okay, so this y is for example survived. Okay,
Mm-hmm.
so we need to consider two cases, survived and
Not survived.
survived. Okay, so if you consider let's say survived, so if I'm asking, hey, in the equation, hey, what is the probability of getting survived given that his age is this much, his class is etc. etc. The formula here you need to find out given that he is survived,
Mm-hmm.
what is the probability of his age is this much. Given
Yeah.
he has survived, what is his class is let's say 3. Given he is
Yeah.
survived, what is its fare ticket price?
Yeah.
Okay.
Hmm. Hmm.
And then what is the probability of the overall surviving?
Yeah.
And then what is the probability of each individual feature?
Feature.
Like what is the probability of age becoming this much? What is the probability of gender? What is the probability of fare?
Yeah.
Correct? Just a formula.
Yeah.
Able to relate?
Yeah. Clear.
Okay, fine. So now we'll try to solve this. Okay, a
Hmm.
simple but very interesting example. Okay, so then you can directly understand that in the next class we can understand the text classification. Okay, so if you see this here, what it's saying, we have vehicles. Okay, 10 examples vehicles. So first vehicle is a red color. It's a sports and it's a domestic.
Mm-hmm.
Okay, it is stolen.
Yeah.
Fine, and like that we are having different types. Okay, so it says yellow color SUV. It's a domestic. It is not stolen.
Yeah.
Okay, now given this, what is the probability of if given red SUV domestic?
Mm-hmm.
Okay, so there is no this combination. You see, red SUV domestic is not there here. So I'm
Yeah.
saying a new car is there that is red color and SUV. It is a domestic. What is the probability that it is stolen?
Okay.
Whether it is stolen or not, we need to tell.
Yeah.
Is a clear problem statement?
Yeah, clear.
Okay. So over here, if you write, that means what is the probability given X? This is given.
Given. Yeah.
Okay. X is given. Then what is the probability of Y?
Mm-hmm.
That is stolen or not.
Okay.
Okay. So here, so this will become, for example, this is yes or no. Yes,
Mm-hmm.
comma, no, I'm writing.
Okay.
Okay. So for this, I need to calculate two things. One is probability of yes given the features, and also probability of no
No.
given the features.
Mm-hmm.
Correct?
Yeah.
Now, if you see probability of yes
What?
with respect to X means what? Now
Probability
probability of,
of
first of all,
y by.
probability of Y with respect to X is probability of Y into probability of each feature given Y. Okay. So
Hmm.
first of all, I'll write probability of Y here. Okay. Into probability of each feature given Y. That means probability
Yeah.
of X1 given Y, X2 given Y,
Mm-hmm.
like that.
Yeah.
Agree? By
Yeah.
probability of each X,
Each
X1,
feature. X1,
X2.
X2. Mm-hmm.
Clear? And now probability
Yeah.
of no, this one, probability of no given X is what? First of all, probability of no
Mm-hmm.
into probability of X1 given no and X2 given no, like that.
Okay.
Okay. By probability of each individual X1,
Feature.
X2,
X,
like
X.
that. Correct?
Yeah.
Okay. So now if you see the denominator is common,
Hmm.
fine. So we can ignore the denominator. In the previous
Yeah.
example also we saw, right? So denominator
Yeah.
is
Yeah.
common here in
Yeah.
example. So this is common. Even for C or T also, the P of A is common.
Yeah.
Correct? So here also, instead of, we can, here we are comparing, right? So we
Correct.
don't need this. Okay. We can, they cancel each other.
Correct.
Agree?
Hmm.
So now to calculate P of Y, we need this. P of Y into each of the probability given Y, P of N into each of the probability of feature given N.
Yeah.
Okay. So to do this, we have a small concept called as contingency table.
Okay.
Very simple concept. So that means it's just writing, creating a table in such a way. For example, for example, you are having boy and girl. So how many
Mm-hmm.
eat sneakers? How many doesn't eat sneakers? So if you
Okay.
calculate,
Okay. Okay.
right, so this is
Yeah.
it's
Yeah.
same like conversion matrix,
True.
like true, actual, prediction. What is the, you know, those values TPT and FPFN. That is, conversion matrix is a type of contingency table.
Hmm.
Agree?
Agree.
Fine. So now with that, first we'll try to create that. Okay. So for example, if I just try to insert okay. So over here, if you see, first of all, I want what I want.
Probability of true. Right.
Yeah. So over here, if you see, where is my pen? Yeah. So over here, P of Y. Okay. So this will become, see here. First, I'm calculating P of Y.
Mm-hmm.
P of Y is, oh, sorry, Y by X. Okay. P of Y by X is P of Y into probability of X1 Y. Now, here
Hmm.
how many X's we have? 3 X's.
Yeah.
Okay. Now, probability of red given Y into probability of SUV given Y into probability of domestic given Y.
Okay.
Because only for 3 features we need to calculate, right?
Yeah.
Given X, I'm saying probability of Y given X. What are given? These are given.
Yeah.
Okay. So for these three only, we'll calculate this. So
Hmm.
X1, X2, X3.
Yeah.
X1, X2, X3. Clear?
Okay.
Okay. So now if you see, first of all, with respect to red is color, right? So over here,
Hmm.
what we can do? So I'm saying this will become color. Okay. This will become yes. Okay. This will become no. Okay. So in color, how many colors we have? You have one is red
True
and
color.
one is
Yellow.
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 Okay. So sorry. So now, first of all, if you see probability of Y, okay. So what is the probability of Y here? Probability. So overall here stolen is 1. Okay. So in that you have yes and no.
Yeah.
So
Total
overall, how
two.
many are there? 10. In
Total
that
10. Yeah.
probability of Y, 2, 3, 4,
Y
5.
and means yes.
Okay. Probability of
Yeah.
Y is 5 by 10, 1 by 2. And what is the probability of no will be?
5 by 10, 1 by
5 by
2.
10. Okay, fine. So now probability of y is 5 by 10. That we let's put it aside. Okay. Now probability of r with respect to y. That means color. So when you're saying here color, so what is the probability of red given that it is y? Okay. That means r by y. Given it is yes. Okay.
Yeah.
See what is r by y? Probability of red given it is y. That means y
First,
is
yeah,
already considered.
yeah,
Okay.
yeah,
So
yeah,
that means what
yeah.
we should consider y rows. So this is one row, this is one row, this is one row, this is one row, this is one row. There are
Out
five
of this,
y's.
red.
Okay. Out of this, how many red are there?
1, 2, 3. Total 3.
Okay. So it will become 3 by 5.
Yeah.
Correct. And red, but no, how many it is there?
No.
We don't need that, but we'll just calculating. We need only r by y, but for calculating no, also we're doing. So for no, how many?
Total 5 reds means remaining 2 by 5.
Correct. So it will be 2 by 5. Correct. So yellow, given it is y. Y is 5. So yellow are how many? Given red.
Total total 10. 10 means out of rest 5. Out of 5, we have
No, no,
only
no.
yellow, right?
Yellows. In yellows.
Yeah, yeah.
And yellows and yes. Yes and yellow.
2, 2. 2 by 5.
1 and 2. Okay.
Yeah.
These are 2 by 5. Now
And 3
no.
by 5. 3 by
3
5.
by 5. Correct.
Hmm.
So now what we are going to do? R by y is what? Given it is y. Yes. What is the probability of
3 by
getting
5.
R? It
3
is
by 5. 3 by
3 by
5.
5. Okay. Into now what is this SUV? SUV will come from what? Type.
5.
Okay. So over there, what we'll do, we will again create one table. Okay.
Mm-hmm.
And here also again we need one more table. Okay. So this is contingency table. Okay. Here
Yeah.
we are having type, and this will again become yes. This will again become no. In type, how many you have? You are having sports
2
and
type.
SUV. Okay.
SUV.
So now, uh,
Sports with the Y.
yeah. So these lines are confusing. Okay. So when you
Y
see
with sports.
sports and yes, so S is having here. So sports are only five in this
1,
five.
2,
1, 2,
3.
3. Correct.
Total 4 years.
4 SUV, 4 sports.
In bottom also we have one, right?
Oh, sorry.
Sport.
Correct. Yeah, correct. Perfect. 4 by 5. Okay.
Mm-hmm.
And in the no, it will be
1
only
by 5.
1 by 5. Okay. And coming to SUV, yes of SUV
We have
are
only
1,
1 by 5, 4 by 5.
4 by 5. Okay. Fine. So let's do it for what is this? Origin also. Origin yes, origin no. Okay. And origin it is domestic and it is imported. Okay. And
Yeah.
domestic, yes and domestic are this is
1,
1, 2,
2,
only 2, 2 by 5. Okay.
2 by 5.
This will become 3 by 5.
3 by 5.
Okay. And imported are 1,
2,
2,
3.
3,
3 by 5. 2 by 5.
2 by 5. Okay. Now we got this. So now quickly, if you see here, this is P by Y, R by Y, and this is P of S by Y. What is
4
S
by
by
5.
Y? This is 4 by Y.
4 by 5.
Okay.
And 2
And
by 5.
2 by 5. Okay. When you do this, you are going to get probability of
Y by
Y by
Y,
X.
Y
Okay.
with respect to
Similarly, when you go for probability of X with
N
respect
by
to
X.
no, so
Yeah.
it will
Yeah.
have probability of first no
Mm-hmm.
into probability of given no, what is red, correct? Now
Yeah.
probability of given no, what is SUV, and probability
Mm-hmm.
of given no,
Yeah.
what is domestic.
Domestic.
Okay. So now this you know what is probability of P by N?
5 by 10. Same.
Correct. 5 by 10. And R by N is 2 by 5.
R
S by N is
1 by 5. 3
uh,
by 5.
S by N is SUV and
Oh,
no,
okay, okay, sorry, SUV, right? 4 by 5.
4 by 5. And domestic and no is
3 by 5.
3 by 5. Okay. So you calculate this. Okay. For example, I'm just assuming this is like 0.7. Okay. 2. Okay. And this is, I don't know, 0.12. Example. Okay.
Mm-hmm.
So now because the probability of y by x is greater than, so I will say this will belong to y.
Okay.
Okay. Y is what? Yes. Yes, means stolen. Yes, this is stolen. So if the car is red SUV domestic, there are high probability that it is stolen.
Okay.
Clear?
Yes, sir.
Okay. So this is one example. So you can extend this example, okay, to many other cases. So here you can have 3 cases.
Yeah, got it.
You can have more classes. Okay, now we have turned this into a classification problem, correct?
Yeah,
So if
yeah,
you have the features and this is your output, so if you have more classes, so instead of yn, you can have more.
yeah,
Okay, so like Setosa, Virginica, versicolor. For Setosa
hmm.
also, Virginica also, versicolor also will calculate. Okay,
Yeah, got it.
so that is numerical values you have over there, so that we will see. But for example, you in some other case, party. Okay, so which party is going to win? So five parties, you will calculate probability for each one.
Yeah,
Okay, so and this is just an extension of formula. So for each feature, you will calculate the probabilities. Okay,
yeah,
so all this is coming from where? It is coming from the Bayes theorem itself. Okay, so with
yeah,
this
yeah.
simple Bayes theorem and Bayes theorem coming from conditional probability.
Hmm.
Okay, so from the simple Bayes theorem, so we are able to extend it and use it for our this one. Okay, so this is our input features. Okay, how many features you
Okay.
have? Those many features. And here you need to consider all the possible classes. Yes, 0, 1, 2, 3. Okay, and just next once you have the formula, and it is important if you are able to create these tables, you can directly also you can pick from this. Okay, but it is very easy if you do this. Okay, once you get this, just putting the formulas and calculating the value. Clear?
Yeah, clear.
Okay, fine. So I would say this is one of the good example. Okay, to understand Navier. Fine. So I would say that's all for today. So tomorrow we'll see. I mean, in the next session, we'll see one more very famous example of this.
Mm-hmm.
Okay,
Okay.
this will give us more confidence, and then we will directly dive into the actual naive Bayes thing, and we'll see if there are any theory and example. And after that, we will also uh, cover the coding of the naive Bayes. Okay,
Okay. Okay.
right. I hope the class is clear, right? So
Yeah,
if you have any
clear, clear.
confusion, just try to see the class once again. It should be clear. Okay,
Clear. Yeah.
fine. Thanks, Karthik.